Hello students, atomic structure, quantum mechanics. So let's practice this DPP. There are 4 questions, you read them and then you try to attempt after pausing the video, then we'll have the solutions. The first question says the wave function psi expresses the following. You see, we know that wave function has something to do with the electron and it represents a wave distribution of probability of electron, but the actual probability of electron is not equal to psi. That means this option is not there. Probability density also, it is psi square. Probability function is also equal to psi square into 4 pi r square. So actually psi has no physical meaning because unless it is taken as a square, it does not acquire a meaning. So option D is the most appropriate choice over here. That means it is related to probability, but it is not equal to probability in any way. So it has a probability amplitude, I would say, just like a wave distribution, which has no physical meaning. Now here comes the second question. Which of the following wave function is not acceptable for an electron in an atom? If you recall the properties of wave function, then it must be very, very smooth. It must be asymptotic for an electron in an atom because probability should vanish at infinity. And it should be properly differentiable. It should be single valued. So you can see this is a broken function. It is not connected to this point. So this is not acceptable. So A is the answer. This is well defined. It can be clearly seen. It is very nice. So C option, you can see there are 2 values of psi for this radius coordinate. So it is also not acceptable. And you can see the kink, the sharp corner. That means it is not a differentiable wave function. So A, C, D are the options. It's a multiple case. So here comes the question 3. We have a wave function represented like this, where this is a constant thing, right? It is not a variable, it is a constant. Now question is asking which wave function, which orbital is represented in this wave function. The first thing you notice that it does not depend on theta, it does not depend on phi, that these are gone. That means it is not a PD kind of orbital. So these are eliminated. So you have now choice 3s and 2s, 3s and 4s, I would say. You can notice it's a quadratic equation. That means it has 2 roots. So that means there are 2 radial nodes, right? There are 2 radial coordinates for which the psi will vanish. And you can also see the denominator 3 over here. So we are confirmed that it is a 3s orbital. Now fourth question says, the wave function vanishes at 2 finite radial coordinate values and is independent of the azimuthal and co-latitude. The orbital angular momentum for this in the unit of h upon 2 pi would be. You can clearly see it does not depend upon azimuth any phi and co-latitude any theta. That means it's a spherical system. And for spherical orbital, that is L is equal to 0. So angular momentum will also be 0. So that's a simple discussion of these questions. Thank you.